Um,
Still remember why it's conduction, convection, and radiation?
conduction, is it that the one that's like heat energy being like transferred to like one from the hot end to the low end, I mean to the cold end.
Mm, 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 mm.
So that is conduction.
To be fair, the one that you mentioned just now actually applies for all of them. I believe for all of them, the heat energy is going to get transferred from the hotter end to the colder end. For all of the
Um,
conduction, convection, and radiation, that's the common thing. Is there any difference
okay, then
between
I
them?
think conduction, is it like the particles are like fast, like the particles like passes faster, like in an
Mm-hmm.
motion, like all to like the surrounding and all.
Okay, first and foremost, you should tell me conduction, right? That is actually within solid and another solid. Is that clear?
Yeah, solid
I
and
repeat,
solid.
solid and another solid. For example, if your if you if you touch the floor directly with your feet, that is conduction because there is one solid with another solid.
Yeah.
And convection is like in fluid. Actually, what is meant by fluid? Fluid is like something that can flow around. For example, liquid
So
and
like
gas.
liquid. Yeah.
Do you still remember that when something gets hot, it will expand, and then when it expands, it will get less dense, and then it will like flow up in the sky?
That evaporation.
No evaporation. That's not evaporation. Um, okay, it's okay. I will show you later on. Is that okay?
Yeah, sure.
Mm-mm. And radiation is like in vacuum, the heat is simply like radiated in the form of waves. Okay, first and foremost, you have to help me to memorize. Conduction is within solid. Convection is like for something which can flow around. And radiation is for pure vacuum. Like no particles are going to get involved. And by the way, just now you mentioned evaporation, right?
Yeah,
May
because you
I?
said like that someone or like something will go up the sky, so that is being like the sunlight evaporating like the liquid.
That is involving different states. Like for example, from liquid and then suddenly you turn into gas. Okay, fine, we call that
Yes.
evaporation. But for convection, we don't do that. For convection, liquid is still liquid, gas is still gas.
Okay.
By the way, just now you mentioned evaporation, so can I have two differences between evaporation and boiling? Tell me two differences between evaporation and boiling, thanks.
Boiling is when like the liquid is reaching 100 degrees Celsius. That's when it comes to the surface area. Like that's when the bubbles comes to the surface area. So like that's like boiling. Like the water reaches 100 degrees Celsius. Then evaporation is when like the water that's on the surface of the water, that's the bubbles and all. Then when there's a sun, so the sun evaporates the water.
Okay, just now I love your whole chunk of answer, but actually you only touch on one point. The point which is acceptable is like boiling happens at the boiling point. What about evaporation? Evaporation happens at what temperature, please?
What temperature, please? Evaporation happens. Oh, shoot. Yeah, it doesn't happen 100. It happens when it reaches below 100 or something.
Yeah, below the boiling point. And in fact, you shouldn't tell me 100 degrees Celsius. Did you know why? We never mentioned this is the boiling of pure water anyway. It could be boiling of oil, you know. So please don't mention 100 degrees Celsius. Please mention boiling point instead, all right?
Okay.
Okay, fine. Here is the answer. Have a look. So I'm sorry to tell you that your answer just now actually could not get you any mark. Did you know why? You only mentioned boiling happens at boiling point. You didn't mention evaporation occurs below the boiling point.
Mm.
You need to mention both sides, then only you can get 1 mark.
Mm.
And would you like to give me another difference between the evaporation and boiling process?
Another process.
Another difference, please.
Like I told, like, evaporation, right? Like
Mm,
evaporates like on the surface of where the water is in, or like I mean
mm,
where the liquid
mm,
is. Then
And then
boiling, the water comes up surface, but
boiling occurs throughout the
like
liquid.
toward the liquid. Okay.
Because if you notice how the water is boiling, right? Actually, the bubbles can be
Mm.
formed anywhere, like anywhere within the liquid.
Yeah, it happens in the bottom as well.
Yeah. I mean, a lot of students will believe that. They will believe that they thought the bubbles come from the bottom. But actually, if you notice carefully, the bubbles don't really I mean, some of the bubbles are formed at the bottom of the liquid, but some of them are formed within the liquid itself. Like suddenly within the liquid, there's one gas bubble appearing out of nowhere. Mm-mm.
Mm.
Okay, how much to remember? This is the key point. Okay. I
Okay.
appreciate your answer to mention a lot of details, but in exam, those details might not really contribute any marks. All right. But I appreciate that. I
Mm.
appreciate that. Okay, so far so good.
Yeah, so far so good.
Mm-mm. And talking about evaporation, right? There is a very famous question. Okay, now let's say you are now working out. Okay, you are now working out, and then there are some
Okay.
sweat. There are some sweat all over your face. Do you think
Mm.
the sweats actually cool you down, or make you even hotter?
It's actually like taking out the heat from your body.
Yes. So they are actually cooling your body down. Okay,
Yeah.
now the question is, how does evaporation reduce your temperature? Question mark. And then there are 2 marks.
Mm.
2 marks. You can find the answer somewhere on the screen here.
Okay.
Mm.
So basically, right, like when you're, let's say if you're sweaty, so that's basically like, liquid.
Mhm.
So what does the evaporation do is it evaporates the liquid. So therefore it cools down the body. It's basically
So
taking out the
far, so far I haven't heard any key point yet. Mm-mm.
heat.
Okay, or maybe I should tell you the 2 marks directly. Okay, listen here.
Mm.
You will tell me like in evaporation, the more energetic molecules can escape into the air. And then the less energetic molecules remain in the liquid. Okay, 2 marks.
Okay.
I repeat, in evaporation, more energetic molecules escape into the air. And then the less energetic molecules remain in the liquid.
Mm.
And you know that less energetic basically mean they are cooler. So you know that the liquid will become cooler. Mm-mm. Okay, so these are the 2 points. You can
Mm.
stop talking about the other points which don't really contribute any marks.
Mm.
Okay, so far so good.
Yes, for sure.
Okay, which leg do you think it will feel colder?
Which one?
Next, look at the screen. Which leg will feel colder?
Which leg will feel colder? Concrete. Hmm. I would say maybe the concrete floor, but normally it's actually marble floor that really makes you feel cool. But concrete floor, not sure.
Yeah,
Uh,
just take it as marble floor, fine. Forget about the word concrete.
mm,
Just change it into marble
that's
floor.
supposed to be the floor, the
Yes.
left leg.
You know why? Why? Why the floor why the leg in direct contact with the marble floor will feel colder?
Because the light is kind of reflected. So in the left leg, because it's like solid to solid or something.
But are you sure you want to use the word reflected?
Then instead of reflected, maybe just say conduction.
Yes. Mention the word conduction. Don't mention the word reflect. Come on, get it away.
Hmm.
Okay, fine.
Okay.
So you are going to tell me the marble floor is very good at conducting heat away from the leg
Yeah.
because on the other hand, the mattress, or the cloth or whatever, which is an insulator,
Hmm.
okay? So the insulator, the mattress, is not very good at conducting heat away from the leg. Are you okay?
Yeah.
The keyword is conduction, okay? Conducting heat away, okay?
Okay.
And I'm going to ask you a question where most people will really get it wrong.
Hmm.
Now you tell me, the temperature of the marble floor and the temperature of the mattress, right? Which one has a higher
Yeah.
temperature?
Which one has a high temperature?
Marble floor or the mattress?
Mm, isn't it? Wait, so this is related to thermal equilibrium, right?
Can you imagine that now let's say in my room, I put a mattress on the floor, and then now I'm going to measure the temperature of the floor. I'm going to measure the temperature of the mattress. Okay, and then that means I don't really touch them. I simply leave the floor and the mattress as they are, and I'm going
Okay,
to
but the
get the
thing,
temperature.
mattress, right? The mattress, right, isn't a solid.
So
So it isn't it isn't heat conductor. I think it's a insulator.
So can you answer my question directly? Which one has a higher temperature?
So, so the one that has a high temperature would be the mattress.
Okay, fine, wrong. So actually, both of them have the same temperature. Okay.
Also, that means it is thermal equilibrium because objects in contact have the same temperature.
Yes, you can say that.
Okay.
I want to ask this question to students because I don't want them to believe that. I don't want them to believe that. Oh, fine, teacher. The mattress is hotter. That's why the leg is hotter. The floor is colder. That's why the leg is colder. No, no such thing. In fact, you should
Mm,
understand that mattress and the floor, they are exactly at the same temperature. But the reason why your
mm,
leg feel colder when you touch the marble floor is because the marble floor is so good at conducting heat energy away from your leg. So you imagine that the
mm,
floor is sucking the heat energy out from your leg. That's why you feel colder. Okay?
mm,
But then the mattress, which is an insulator, they are not really good at sucking the heat energy out of your leg. But of course, don't use the word suck, use the word conduct, okay? Conducting. So that's why you
yeah.
feel hotter. You get me? And the very same reasoning is like this. Like when you go to a government hospital, this is most probably the chair that you are going to sit on. You know, for some unknown reason, the chair is made out of metal, which is really cold, you know, like when you are in an aircon, the metal is really cold. But luckily,
Yeah.
the place that you are going to sit down is like some rubble, rubble or plastic, rubble sheet, okay? But you should not say that. You should not say that rubble has a higher temperature than the metal, which is obviously wrong. Because
So you're
they
just
have
supposed to
the
say it's just an insulator.
yes, both of them have the same temperature. But the reason why you feel colder when you touch the metal is because the metal is so good at conducting heat energy away from your hand. All right.
Yeah.
You get me or not? Okay.
Yeah.
Okay. So this is conduction, solid with solid. Are you happy?
Yeah.
Okay. I'm going to, but I like it, I like it when you mention the word thermal equilibrium. Like when something is in contact with something, at thermal equilibrium, then they will have the same temperature, and then there's no net heat being transferred between them. All right. Now look at this experiment. I am going, okay, so now you have wood and you have metal, and I'm going to wrap a piece of white paper around the wood and the metal. And you know what? I'm going to use a Bunsen burner to burn the paper now. So would you like to guess what is the observation?
Just observation. Okay. So first, like the paper's wrapped, like the paper's wrapped for the wood and oh yeah, the wood and metal. So that means that definitely the
Mm-mm.
paper will burn first. But the thing is, the metal won't burn
Mm-mm. Why?
because metal is a good conductor of heat.
Mm-mm. So the paper being wrapped around the metal, right, will stay perfect, although they are being burned by some fire. Okay?
Also, the paper also will stay perfect.
Yes, the paper will stay there. You don't expect the
Okay.
paper around the metal will get burned away. No.
Okay. But then the paper that's wrapped around the wood that will burn because wood
Yes.
isn't a good conductor of heat.
Yes. Now have a look at the explanation. So the keyword that you have to mention is who is good conductor of heat, who is good insulator of heat. Okay.
Okay. So I got my
Sometimes
marks right.
sometimes I really need to underline or highlight the keywords, I don't want the student to talk a lot about the content, but they forgot to mention, the keywords like
Yeah.
conductor, insulator. Okay.
Mm. Mm. So then, like after so just now, I mentioned the keyword already, so I already got a mark. Then after that, I have to explain like the like you see in the second point, like it shows that where the paper touched the metal, heat was transferred. So I have to talk about the transfer of heat, right? So
Yes.
okay,
You may
so
change
for
the
the
word
method,
transfer with
mm,
conduct. Mm.
so transfer a conductor. Okay,
Mm. Okay, so far so good.
yeah,
Mm-mm. Okay, okay. Now one more thing is this, and yeah. So basically now you have four different metals. Are you good? Look at the cross here. You have
iron,
four different metals. Huh? Are you okay? Four different metals.
yeah,
And then you have
mm,
some wax. You know what is wax? The wax. Like the candle. Okay. So you have some
mm,
wax to attach the metal ball under the end of each four different metals. And you are going to use Bunsen burner to hit the right center of the cross here. Okay.
okay,
And the purpose of having this experiment is to understand which metal is really good at conducting heat.
oh, okay,
Okay. For example, now, to be fair, I didn't really know which one is so good at conducting heat. Like brass, iron, copper, aluminum. Let me make a guess. Maybe copper. Let's say copper. I don't know. if copper is really good at conducting the heat, then I should expect the ball from the copper rod to fall down first. All right.
Okay.
So you understand the logic, right?
Yeah. So wait, by the way, brass is an alloy metal, right?
Yes.
So wait, is it made of, wait, I forgot which are the two components. Is it made of like copper and then what's another one? Copper and iron?
Well, to be honest, I also forgot already. That is chemistry stuff. All right, so you can ask the chemistry teacher. Okay.
Oh yeah,
I
stuff, yeah.
only remember steel is like iron and carbon. This is what I remember for steel, iron and carbon. But if you ask me brass, I have forgotten. I'm sorry. Okay.
Okay. But I think okay, so in this experiment, right, the best metal that has like good conductor of heat should be copper.
Oh, we don't have to know that. Sorry. Yeah, we don't have to know that. All you need to know is like you need to know the purpose of this experiment. Okay.
So the purpose of this experiment, okay.
You don't have to remember copper or aluminum, which is so good at conducting heat. I can't remember as well. Okay.
Hmm.
Okay. So so you understand the logic, right? I mean, when the heat is conducted here, the wax will melt, and then of course the ball bearings will fall down. All right.
Yeah.
Okay.
Hmm.
Okay. So if people ask you why do you think metals are so good at conducting heat, then you need to mention the presence of free electrons. Okay.
Free
The
electrons.
word free is compulsory. If a student simply mention that we have plenty of electrons in metals, they didn't get a mark. But if you say that we have plenty of free electrons in the metal, then okay, fine, you get a mark.
Hmm.
Okay, the word free is important. You don't like free, you use delocalized.
You could also use, right, there's like one term, C of delocalized electrons.
Also can C. You use ocean, a sea of delocalized electrons. Okay.
Hmm.
Okay, so now, because you actually, in a matter, right, conduction happens so quickly because you not only have atomic vibration, but you also have free electron collisions. So that's why the metal is so good at conducting heat. All right.
Hmm.
Can I move on?
Yeah, what?
Can I move on?
I can't hear you.
Can I move on?
Yeah, I can move on.
Oh, okay. Yes, let's talk about convection. Okay.
Convection.
Convection is like this. It is important to understand that for convection, this is definitely not evaporation or whatever, because the state is not changed here. Okay. So for example, let's say I burn something here. I burn something. So look at the pink color one. Okay. When I burn something, when it gets hotter, when it gets hotter and hotter, the temperature increase. And when your temperature increases, you will expand. Am I right? Like hot things expand, cold things contract. Are you fine with that?
Yeah.
And okay, so when temperature increase, volume increase, so density decrease. Did you know that this is density? This symbol, rho.
Yeah, PGH. I don't know the formula.
PGH. Oh, you mean rho GH, right?
No. I remember the formulas and all because you use P as like for like density and all like PGH and all everything.
Oh, then
Like
you are
there's like
wrong.
type of
We don't call that P. We don't call that P. Seriously. Now look at this. Look at this. Okay. Density is mass over volume. You don't use P to represent density. That's wrong. You use the symbol rho. Okay?
Mm.
And the reason why we never allow students to call that PGH is because you should tell me P equal to rho GH. The liquid pressure is the density times gravitational field strength times height.
Mm.
So that's why it's so funny when students tell me, P equal to PGH. Huh? P equal to PGH? What's that?
There's a different formula. Like if you want to find density, is P equals M over V. Like PJ is for like for different type of thing. Like for
Yeah,
pressure.
that is what I'm trying to tell you. Don't call that P equal to M over V. Please call that rho equal to M over V. Okay?
Rho equals M over V.
Don't call that P. Come on. Okay? Stop talking like P equal to M over V. Just tell me rho equal to M over V. Is that okay?
Okay.
P is for pressure. Rho is for density.
Yeah.
Is that clear?
Yeah.
Okay, having said that, what is P? Pressure. How do you define pressure? Something divided by something. What is the definition of pressure? Come on. Pressure.
Pressure is P equals is it wait, let me guess. Is it P equals force over A? So A should be area. So force over area.
Well done. Pressure is force over area. Well done. And density rho is mass of volume. Okay.
Yeah.
Okay. Good job. Good job. Now come back here. Anyway, when you're so hot, your temperature increases, volume increases, density decreases. And you know what? When your density decreases, you will rise up. Okay. And on the other hand, the cold air, your temperature is so low, volume is so low, density is so high. No wonder you will sink, you will fall down,
Yeah.
right? And look at this. This is exactly how the sea breeze and land breeze are formed. Are you okay?
Yeah.
Let me ask you a question. Sometimes sometimes in Malaysia it's so windy now. Do you think the wind is caused by what? I mean, what object or anything that really caused the wind to form?
The exit cost like the is it known as like the sea breeze like during the daytime and all?
Uh, Not really. I'm referring to all the breezes, all the winds ever. Not really limited to land breeze and sea breeze.
Mm,
Hmm. I'm going
like
to
the wind
tell
is
you.
like when from the hot air to the I mean like from the is it like the when the cold air to the hot air or something?
Actually, that is due to the uneven heating of the Earth's surface by the sun. Okay,
Mm,
like some places are easier to get hotter, some places are more difficult to get hotter. So that's why there's a presence of wind. I'm referring to all kind of winds ever in the world.
yeah.
The most funny perspective is a student tried to tell me like, oh, teacher, there's wind because the earth is rotating. Oh my God, there is a very there's a very big misconception. I know that the earth is rotating, but this does not contribute to any wind.
Yeah.
Okay, so you look at this. Did you know that this is like a cycle? This is like a cycle, yes or no?
Yeah, this is cycle because like it's like the movement of air.
Yes, and you are going to tell this as, I mean, you are going to call that as convection current. Are you fine?
Yeah, convection current. Okay.
Okay, so this is called convection. Nothing to do with evaporation. Are you good?
Yeah, I'm good.
Mm-hmm. So this is basically happen in the air. Now, if I put a beaker, hang on, do I have that here? Yes. If I put a beaker and then I put some liquid here, and then I'm going to put my fire here, you can also notice the cycle. And of course, people are going to put some color, some dye here, so that you can see the color, the whole process is very visible.
Hmm.
So this is also convection.
Yeah, this is a
This is
convection.
not evaporation. Evaporation is like here the water become gas. Then you call it evaporation. Are you okay?
Yeah.
Convection is referring to the movement of the water molecules. Okay.
Hmm.
Now, can
Okay.
I ask you a question?
Yeah.
Please describe convection current here. Thank you.
Convection current here. So
Mm.
basically, the red one is where the wait. So the one that in the middle is that the
Mm-hmm.
volcano?
No, volcano. There is some solid. There's some solid, some chemical
Okay, there's
solid,
some solid that giving
and
heat, right?
and then you are going to burn it.
Okay, so inside the water. So when it's getting heated up, that's when
Mm-hmm.
the heat expands.
You
So when
sure
the
you
heat
want to say the
expands,
heat expand? The heat expander. The heat expand, is it?
yeah, like the thermal energy or something.
So are you sure that you are going to tell me the energy will expand? Is that true? Who is expanding?
Mm, basically like the no, not the heat. So wait, it shows that the color is expanding.
Mm-hmm.
So when the color expands, so heat is being given. So that means heat is
Okay,
supposed to
fine.
be
Stop. You should tell me the hotter water molecules will, I mean, the hotter liquid will expand. You should mention the hotter liquid will expand. You shouldn't even mention color expand. No, you shouldn't mention the heat expand. How can the energy expand, by the way?
so I'm
Mm-mm.
supposed to say like the hot liquid like flow
Will
upward.
expand. Okay, after that.
Okay, so like the hotter liquid like what I mean like flow upward. Then so basically the hot air, I mean sorry, the hot liquid has like a lower density.
Mm.
Then the
Okay,
cold air, I mean the cold liquid has a lower density. I mean has a high density. That's why it falls down.
okay. Okay, so far so good.
Yeah.
So just now, yeah, help me to understand that they mentioned hot gas expand. Mm.
Mm-hmm.
Hot gas expander. Okay.
Hot gas expands. Okay.
I don't want student to tell me that molecules expand. No, molecules cannot really expand.
Mm.
Molecules are that big. Like hydrogen molecule is small, oxygen molecule is
Mm.
big. They
Mm.
can't get bigger just because of heat. Okay.
Yeah, okay.
So you should tell me hot gas expand, hot liquid expand. Don't
Mm.
mention molecules expand. Are you okay?
Mm.
Okay, so this is convection, and this is for something that can flow around just like liquid or gas. Okay. Now I'm going to talk about radiation. And by the way, I think it's good for you to read this at home, but I'm going to point it out for you first. This one.
Okay.
Can the student tell me heat expand? Can the student tell me heat rise? Oh, the heat rises up.
Heat does not rise. It is the hot gases and liquid which is rises. Okay. So I should say like either hot air basically, then or I say hot liquid that rises up because the
Yes, yes,
density
yes.
is lower.
Yes, you're right. Okay.
Mm. Yeah.
Don't ever mention heat will expand, you know. Don't mention
Mm.
heat will rise up or whatever. No, no. Even though we actually know what the student is trying to say, but we can't offer any marks. Are you okay?
Yes, sir.
Okay. Yes, let's look at radiation. Nothing much to show you in radiation because have you learned waves, by the way? Have you learned waves?
You mean the wave?
Yes, like the
Yeah.
electromagnetic spectrum. Have you learned that?
Yeah.
Okay, let me test you now quickly. Would you mind would you mind listing down what are the
Mm.
7 regions of wave in electromagnetic spectrum now?
Like those, no. That's like wait. So you're telling the seven spectrum. So like there's
Yeah.
um,
No, you don't call it 7 spectrums. You call it 7 regions or 7 different ways in the electromagnetic spectrum. We only have one spectrum, by the way.
yeah.
Mm.
Mm.
Tell
Would
me that in order, in sequence. Don't jump here and
oh
there.
no. No. Okay. Okay. Mm. So the first one is electromagnetic spectrum. Is it first the ray? Is it in first? Wait, I think first is radio wave.
Okay, radio wave.
Then microwave,
Okay, microwave.
infrared light, then visible
Okay,
light,
infrared, visible light.
then wait, X-ray? No, it's not X-ray. I think it's ultraviolet light, then X-ray, then gamma ray.
Okay, UV, X-ray, gamma ray, fine. Which ray that you mentioned just now actually contributes to thermal radiation? Out of 7 answers that you have provided just now, there's only one wave which is related to thermal radiation. Would you like to guess which one of them?
Thermal radiation. Is it gamma? Wait, no. 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 Yeah, is it gamma ray?
Wrong.
Then is it radio waves?
No. Okay, I'm going to tell you now. The sun is going to give us 3 different kinds of wave. Okay. First and
Okay.
foremost, I can't believe if a student does not know visible light because that's what makes you
Mm.
feel very bright. Are you okay? It
Mm.
offers colors. Okay, red, red color, blue color, yellow color, whatever colors. Okay, and
Mm.
the answer just now was actually infrared. That's what makes you feel hot under the sun. Without infrared, you wouldn't feel very hot, you know. And finally,
Mm.
there's one more thing, which is UV. Oh my goodness, I can't really use my pen now. Hang on. UV, ultraviolet. Is that okay? Ultraviolet.
Ultraviolet.
Mm-hmm. So ultraviolet will actually, ultraviolet is something that's not good, you know. Ultraviolet, it will
Mm.
give you something like skin cancer, eye cataract. So ultraviolet is no good. We don't like it. Okay.
Mm. Okay.
And you have to understand that no radio wave, no gamma ray. If the sun gives you gamma ray, then we don't have to sit down here preparing for exams anymore because we are now thinking how to survive. All right.
Yeah.
Seriously, if they emit gamma ray, it's okay. We can like celebrate our last dinner tonight. Okay.
Okay.
Okay, how many to jot this down? You need to memorize this. Okay.
Yeah.
So you see, for electromagnetic wave, you don't even need a medium. Am I right? I
So
mean
wait, so
yeah.
the one that helps with radiation is the infrared.
Yes, yes. Infrared is the one which contributes to thermal radiation.
The visible light is just like the one that through like the sun with bright light
Yes, yes, yes.
that you can
All
see.
the colors that you can observe by your naked eyes.
Then UV light is the one like that people can't see or something.
Yes, we can't detect. That is why it makes it so dangerous. Like if only we can see the ultraviolet, actually things are safer now. At least you can detect your enemy. But the trouble is we cannot detect. You cannot say something like, I feel hot here, so I believe there's more gamma ray here or more UV here. No, we can't detect it. We cannot sense it.
Mm,
We cannot see it. So that's why it's so dangerous because we can't really detect it.
mm. Yeah.
Okay, so far so good.
Yes, visible.
Okay, so radiation does not require any medium. So radiation can happen in the vacuum directly, all right?
Mm.
Okay. Do I need to explain more about thermal equilibrium? Have a look. The rate at which you are receiving heat energy is equal to the rate at which you are losing heat energy away. So that's why there's no net transfer of
Heat
heat.
transfer. Yeah.
Uh, if you notice just now, I mentioned the word net. No net
Mm.
transfer of heat. The word net is so crucial. If you tell me there's no transfer of heat, basically you are wrong because it is still receiving heat energy and it is still giving out heat energy.
Yeah, it gives out like one like so like let's say if like in like a line that let's say there's like 5 lines. There's like 4 lines that's giving out energy, but then there will be still one line that will be giving in one energy back. That's why it's
Mm-mm-mm.
like no net transfer of heat.
Yes, yes. So you either use the word net or you use the word resultant.
Resultant. Okay.
If you don't have this kind of keywords, you can forget about getting the mark.
Mm. So the reason why is it saying, I mean, like why, like one of the characteristics of thermal equilibrium is no net heat transfer. I mean, no net transfer of heat is because of there's like a constant temperature where it is like from the node you're showing. So the second point, right? Like constant temperature where it is absorbing radiation at the same rate as it is emitting
Yes.
radiation at this one.
Mm-mm-mm.
This object will be
Yes.
in thermal equilibrium. Okay.
That means, let's say if
So
you
basically it's
receive
in the
5
same
joule
rate.
of energy, you are also giving out
Mm.
5 joule of energy at the same time.
So basically it's like the same rate. That's why it's no net transfer of heat.
Yes, yes, you are right.
Okay.
Okay, so far so good. So that's why your temperature
Yeah,
will not change anymore. Your temperature is a constant now.
mm.
Okay. Okay. So okay, fine. Now I need to have some time to talk about the questions.
Mm.
Uh, have I shown you all these question and answer before? Because what I what I normally ask my student to do, right, is
Mm,
they should go through a lot of question and answer, you know.
mm,
Mm. Because I can tell you seriously, like when you go through so many questions, all the answers will look very similar. So that's why
mm,
I can't really believe if a student cannot pass the subject physics, you know. I can't believe that. Like all the answers are so similar. Why can't you just memorize them and simply pass your exam? You know? Are you okay?
mm, yeah.
Okay, fine. Let's get started with this question now. Mm-mm.
The source of solar energy is the sun. Take the boxes and next to the resources for which the sun is also a source of energy. So coal, yeah, and the sun costs like, so
Mm.
coal, okay. Hydroelectric, yeah, because with the sun only, that's how the hydroelectric energy works. Then wind energy, wait, take the version of the resources for which. So wait, can I know how does the wind is the one
Mm.
is like take because like like wind energy, so basically the wind turbine, right? So it moves because of the sun energy, right?
Mm-hmm. Did you know why the wind is formed? Did I mention that wind is formed due to the uneven heating of Earth's surface by the sun?
Yeah, you mentioned it earlier, like the Earth's surface or something.
Just now I mentioned this, right? That is,
Yeah.
I mean, the sun is the reason why you can have breezes, you can have winds on the earth. All right.
Mm,
So without the sun, you cannot have the rain. Without the rain, you cannot have hydroelectric energy. Without the sun, you
mm,
cannot have the plant. And if the plant don't die, and then if the died plants don't get buried underground, you wouldn't have coal. So that's why sun is the main sources for three of them. Are you okay?
yeah.
Okay, if the sun is not the source of geothermal, then who is the source?
Geo is basically the
Geothermal,
geo
geothermal.
geothermal. I forgot its definition.
Geothermal, you know, like geothermal, for example, hot springs. We pump some cold water down to the underground,
Mm,
and on the other side, we are sucking the hot water out from the underground, and we use the hot water to generate energy.
so the source of energy is from the earth, like the earth underground. So it's not so the you can't take that because it's not really to the sun.
Yes, yes, yes. So have I shown you this before? Wait a minute. Okay, fine.
Mm,
This is geothermal power plant. Look at this. They will simply
mm.
pump a lot of water into the underground, and on the other hand, they will suck the hot water out. And basically, you use the hot water to rotate the turbine and whatever.
Because the earth's surface, of course, it's always hot because of the the magma, the core, and everything.
Yes, yes. And then the
So
heat does not come from the sun though. It comes from the earth.
it's
All
all
right.
underground. Yeah, it comes from the earth.
Uh, and by the way, have you learned how does this work? Like for example, nuclear power plant. Okay, this is nuclear power plant. Like when you have some water and then water, the water will get heated up by the nuclear things. Okay, like by the nuclear fusion, and then the water will turn into steam, and then the hot moving steam will rotate your turbine. When your turbine is being rotated, your electric generator can generate some electricity, and then the electricity is going to get transmitted away in the transmission lines. I mean the cables are the cables. All right.
So it's like so the sources for like nuclear energy is like the nuclear fusion and fusion.
Yes, yes, yes. Okay, sorry. In fact, that is nuclear fission. Nuclear fusion happens in the sun. Yeah. So nuclear fission is present in nuclear
Is
power
that
plant, atomic bomb, and whatever.
okay. Then what about oh, so wait, so the only one that is not supplied by the energy, I mean by the sun, is the nuclear fission. So that means nuclear fusion and nuclear decay happens in the sun, right?
Wait a minute. You should say nuclear fusion happens in the sun, and nuclear
Yeah, nuclear
fission.
fusion. Yeah, nuclear fusion happens in the sun. Nuclear fission happens in a power plant. But there's also another source which is called nuclear decay or something.
No, nuclear decay is like nuclear fission because the uranium
Oh,
decays into, let's say, thorium, and then thorium will decay into blah 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 blah. That one. So
okay.
basically, we only have nuclear fission and nuclear fusion. Nuclear decay is
Mm,
like it's like another word
nuclear
to
fusion.
describe them.
Wow, okay, okay.
Because sometimes students cannot understand why the hot water can generate electricity, So that's why we need to show them that, okay, fine, you see the hot water will turn into steam, and then the steam will be moving so fast. When the steam is
Yeah,
moving
because of the
so
turbine.
fast, it can rotate the
Mm.
turbine. That's why, right?
So when it rotates the turbine, it creates electrical energy. Lah.
Yeah. So that means the core principle of generating the heat energy is you need someone to rotate the turbine. Is that right?
So the
Either
one
you
that rotates the turbine is the steam.
It's the steam. Yes, it's the steam. The hot moving steam. Mm-mm.
Mm.
Okay. Okay. And wait a minute. Have you learned how does generator work in topic 4, electricity and magnetism?
Topic for the forces and energy, is it?
No. Topic. Okay. I mentioned topic dot chapter. Topic 4 is the electricity and magnetism.
Oh, for me, it shows in the book, chapter 8.
Oh, then it's okay. Then there's your chapter. I'm talking about topic dot chapter
Mm.
because chapter is like how your reference books are going to arrange them.
Yeah.
But topic is decided by the what? By the syllabus already, so we can't change that, all right?
Mm.
I mean, have you learned this already? The Fleming left hand rule, Fleming right hand thumb rule.
Yeah, that one. Yeah, sometimes I get confused. So that one's like after we do this chapter, we have to do that as well. Because that one,
Mm,
like sometimes I get very confused.
okay. But last time you mentioned that you actually set for IGCSE before, right? Or what?
Yeah.
Okay. So anyway, this is your second chance, is it?
Mm.
Okay. Okay, coming back here. Oh, where is it? Okay, so let's move on to the next one.
So this one, cold water flows into copper tubes, which are heated by solar radiation. Copper tubes, why tubes are made of copper and are painted black. So yeah, like I told earlier, so copper is the one of the very good conductor of heat, like heat and all. So that's one
Mm,
reason. But black surface, oh, because like okay, so like why people like have like for a reason like why people don't have black cars is because it absorbs a lot of energy. But why people have like so that's why people have white cars because white color cannot absorb the sun radiation. So that's why it's painted black so it can absorb all the heat energy like from the solar.
mm. But you need to, okay, wait a minute. Once again, I need to tell you you need to be very careful. For example, if a student is trying to tell me white surface cannot absorb the heat, fine, you're wrong. Later on, you can check back the recording. Actually, this is what you mentioned just now. We need to tell student that you can only mention white surface is not good at absorbing thermal radiation. Okay, that is correct. But you cannot tell me white surfaces cannot absorb heat energy. That's a wrong statement. All right.
Mm.
You get me out? Like if you say that it is very poor at absorbing radiation, it means that it's not good, but actually it still can absorb a little bit. Okay.
Mm.
So you need to be very careful with the statement here. All right. They will try to find any way to deduct your marks. And most of the time, students believe they can do well in exam because they can answer the questions, but they don't really get some high marks because of this kind of mistake. Okay.
Mm. So I'm supposed to just see like black surface. Why is it painted black? I mean, why is it painted black? Because black surface is the best absorber for like radiation and all.
Okay.
Okay.
So you see, the difference is what you know. Now I mentioned that black surface is the best absorber of radiation, but actually I didn't say that black surface can absorb 100% of the radiation. You know.
Mm.
You get me the difference, right?
Yeah.
Okay. And have I told you that Q equal to ML basically is no longer in your syllabus? You only have Q equal to MC delta T now. Are you good?
Yeah, you told that earlier. So
Oh,
wait, so Q is the energy, right?
thermal energy.
Okay, Q is the energy, M is the mass,
Wait,
C is
I
the
said
charge,
thermal
right?
energy. I said that thermal energy. You should be more precise there. You shouldn't
Oh
tell
yeah,
me
thermal
energy.
energy.
Uh,
So then M is the mass, C
okay.
is the charge, right?
No, C is the specific capacity.
Oh, specific heat capacity.
Specific
So
capacity. The charge that
oh,
you
okay,
mentioned is
specific.
this one. Like let's say the charge is let's say five. Wait a minute, 1.6 times 10 power negative 19 coulomb. The C that you mentioned is probably the coulomb here, isn't it?
Yeah.
Which is basically a unit of charge.
Hmm.
And
Okay,
basically
so
the Q
so that
here
means
means
C is the
charge.
specific capacity.
Yeah, small letter C, because the coulomb here is capital C, capital C. And then the
Hmm.
small letter C here is specific heat capacity, all right?
Oh, okay, okay. So then the theta is the difference in temperature, the change in temperature.
Yes, the change in temperature.
So they already mentioned 0.019 kg, which is the mass and all. So you add that, then the specific capacity is 4,200 joules per kilogram degree Celsius. So that's 4,200. So multiply that, and then change in temperature is it shows 20 degrees Celsius to 72 degrees. So you will have to minus it, which is 72 degrees minus 20 degrees, and you put that in the calculator, you get 4,149.6 joules, and then you have to round it up.
Mm.
Hey, why do you have to round it up?
Oh well, that is a general rule in exam that we have to present your
Oh, two
final
significant
answer.
number, right?
Yes, in two or three
Oh, yeah.
significant
Okay.
figures.
Okay. That's why 4,100 joules. Okay.
Mm-mm. Now I'm going to ask you, why do you think that you can actually use degree Celsius? Because normally we are using Kelvin, isn't it? So why do you think we can safely use degree Celsius here?
If we want, wait, we can just change it to Kelvin.
But will it make any change to the answer?
Wait, let me just try to change it to Kelvin and just do the minus thing first. Okay.
Mm-hmm.
So 0 degrees Celsius equals to 273 Kelvin. So 72 means so plus 273, which is
Yes.
uh,
So like this.
345, 345, and then 20 plus 273 is 293. So 345 minus 293 is 52. Yeah. Wait. Yeah. It doesn't make a difference. It's the same.
Because actually I was hoping that you can tell me what I told you last week. Last week, do you still remember that I mentioned for change in temperature, 1 degree Celsius is basically 1 Kelvin? And I mentioned that
Yeah, you
temperature,
told.
I mentioned that for temperature, 1 degree Celsius is definitely not equal to 1 Kelvin, It will be equal to 1 plus 273.15 Kelvin. Are you good?
Yeah. So
And
change in
remember
temperature,
this,
the degree
yeah,
Celsius and the Kelvin is the same. But when it comes to temperature, that's the one. 0 degrees Celsius equals to 273 Kelvin. Like that.
Yes. Okay. In fact, this was a question last week, if you still remember, okay?
Yeah.
Okay. But once again, I have shown you that actually nobody will. I mean, seriously, no one will do this. It's just a waste of time to prove that they are the same. Okay.
Mm.
Okay.
So efficiency. So now we have to find power. So power, there's like power is equals to uh,
Definition of power. Definition of power, please.
definition of power is the one that gives out energy flow or something.
What is the definition of power?
Uh, is it like the energy that's being like transferred or something?
Energy being transferred, and then that's it. That's all.
Is it like the rate of work that you told that last week something?
Okay, rate of work done. You either mention work done divided by time, or you can mention energy transfer over time. So that's why just now I was hoping that you could tell me if the energy transfer divided by time, then you are correct. Okay. Or you can mention rate of energy transfer or the rate of work done that you mentioned just now. Okay.
So because like this is the work done power, this is not the electrical power.
What do you mean electrical power? Okay,
Because
fine.
it's like different power formula.
Whether that's electrical power or maybe the power coming from the sun, that is something that you have to check in the question. For example, let's look at the question. Today, this is the solar panel. So the power in must be from the sun, right? The power input for the solar panel must be from the sun. And the
Yeah.
power output of the solar panel will be the what? Will be the energy used to increase the temperature divided by time, no? Meaning that who
So
is
that
the
means
input power, who is the output power, it really depends on the question. You need to check what is the item.
so basically the input power is the sun, right?
Yes, is the input power is coming from the sun. Yes.
Then the output power is the specific capacity.
You should say thermal energy divided by time.
Thermal energy divided by time. So now we already found the efficiency is 70%. So efficiency formula is, what's the efficiency formula?
Oh, efficiency formula is like this. The power, okay, useful output power divided by total input power multiplied by 100%. Or
Okay, so
if or you can change the word power into energy, which is useful
useful
output
energy.
energy over total input energy multiplied by 100%.
So useful output energy over total and input energy times 100%. Okay. So the total, I mean, so the output energy, useful energy output is energy output. So the useful energy output can be known as MCQ. I mean, MC equal Q theta.
MC delta T
MC
over
theta,
time.
MC theta over T. Okay, so MC theta over T. How do you find MC theta over T? There's no, like, they didn't give the mass, they didn't give the
Oh,
specific
really?
capacity.
Oh, really? What did you do just now in the last question?
Oh, it's a continuation. Okay, it's a
Ah,
continuation. Okay. So in this one, do I have to give the rounded up number or should I give the actual number, like,
when you
4,100
are doing
joules?
the
Or should I give...
calculation, when you are doing the
Mhm.
calculation, please use the very complicated numbers. I want the correct answer. Okay, I want the
Okay.
most accurate answer.
So then they said in the number two question they say later after that 5 seconds. So the time is 5 seconds. So five. Then the total energy output we don't know. We don't know the total energy input. Sorry. So what we have to do is we have to bring the but why is it known as PIN? I mean pin.
Oh, come on. Power input. Power input. So we simply call it
Oh, the second is up. Oh, okay. So then
PIN.
the pin will be going to the left hand side. So that's the subject. That's the one we're trying to find out. So then it will be 41496 divided by times 100%. That's 100%. Therefore, we get 829 times 70%. From figure plus 580.944, which is 6 million. So 100% divided by 70. Wait, so when I bring the pin, the other side, so the 70% goes down, right? Does it become the
Yeah.
denominator or something?
That means if you want to find the input power, 4149.6 divided by 5, and then that will be divided by 70% times 100% here. So press a calculator.
Then times 100%, which is, well, it shows 580.944.
Let me say press a calculator wrongly. Now follow me. Press a calculator. 4149.6 divided by 5. Press enter.
Okay,
And then press answer divided by 70. Press enter.
okay, times 70, then enter, then,
I said that divided by 70.
or divided by 70, okay. So divide by 70, okay, then enter,
And then
then
answer multiply by 100.
multiply by 100, okay.
Enter.
So, oh, okay, so now I get it. Okay, so
Mm,
5 times 70 times 100. I get 1185.6.
okay.
Yeah,
So, oh
so
my
basically
goodness.
the denominator comes the 4149.6 divided, then the denominator, which was 5 earlier, goes down. Then it has to multiply with the 70. So it times so 5, so 4149.6 times 5 times 70. Then that form that fraction times 100 equals to 1185.6.
Hmm.
Then after that, when I want to put the answer, I put in its two significant number, which is 1200 watts, because watts is the SI unit for power.
Okay. Okay, so far so good.
Yeah, supposed to be.
Now, this is what I asked you last week. Do you still remember how to define the specific heat capacity?
You told me it was like the thermal energy that like the temperature increase of the because MCQ I mean the theta is like that the 1 degree Celsius and the 1 Kelvin is the same, so it shows that the 1 kg mass has to be like divide I mean has to be times with either 1 degree Celsius or 1 Kelvin or something.
Mm-hmm.
So yeah, that's the answer.
But it seems like you love to, how do I say it? Okay, fine. When it comes to definition, just memorize it.
Mm.
Thermal energy required to increase the temperature of 1 kilogram of mass by 1 degree Celsius. Full stop.
Mm.
And if you notice, this actually comes directly, directly from the equation Q over M delta T. Am I right? Energy
Mm.
divided by mass and then divided by change in temperature.
Mm.
For definition, I hope you can simply memorize it.
Thermal energy required to increase temperature of 1 kg of mass by 1 degree Celsius 1 Kelvin.
Now let's move on to the next question.
This is the last question, right?
Mm-mm.
Then student carries out an experiment to find a specific capacity of aluminum. So following data is obtained: hour, time, mass, initial temperature, and final temperature. So they basically didn't give Q, which is the energy. They didn't give the thermal energy
Yes,
like the
they didn't give
equation.
an
So they say power time, but and I remember in the last week you told energy and PT is the same.
yes, energy is basically power multiplied by time. Yes.
Yeah, power multiplied time. So we already got power and time, which is 420 watts times 95. And then so 420 times 95. Okay. So then the next equation, like the equals to MCQ theta. So M is 2 kg, so 2 times. Then specific heat capacity, we don't know. That's why we're finding out. So that is like dash. Then we already know the final temperature, initial temperature. So the final temperature minus initial temperature, we get 40.5 minus 19.5, we get 21. So then 2 kg. So wait, so then specific capacity goes the other side. And then wait, let me just write down the question. So 420 and then 95 goes to 2 kg. C we don't know times 21. So the do we bring so we bring the C to the other side. So which makes it the 420 and 95. So we multiply that, right?
Multiplied by what?
The PT, we multiply the PT. So 420 times 95, we get 39,900. Yeah, so 2 times, so yeah, 420 times 75, then like 2 times 21. The multiplication comes with division. When it comes to division, it is fraction 420 times 420 times 95, which is 39,000, then divide by that with 21 times 2, 21 times 2 is 42. So 39,900 over 42 is 950. So the specific capacity is 950 joules per kg degree Celsius.
Yes. And finally, for question C like this, right? You know, my advice is you are going to pick 2 or 3 of them and please memorize them. Like simply memorize them. Are you okay?
Yeah, we have done this question before.
Yes. Okay.
Hmm.
Okay. So for this week of homework, I'm going to send you this, and you know what? Actually, I'm a really flexible teacher. You can pick
Mm.
any 10 pages that you feel like you are confident to do, then you do that. Is that okay?
Mm. Okay, yeah, sure.
Of course, the more you do, the better lah. The more you do, the better. I'm not going to give you an upper limit. All right, the more you do, the better
Yeah.
is okay.
Mm.
All right, so far so good.
Yes, it was a good.
Okay, so if you notice, basically we have quickly like briefed through everything in this topic 2 thermophysics. So I really need your help to go back home and read these notes, which have 68 pages. Oh my god, that's crazy. So 68 pages. Help me to go through them at home. I can't possibly like help you to read every single line of these notes. All right.
Mm. Yeah.
Okay, so far so good.
Yes. Oh, so far so good.
Okay, and for this coming Thursday class, don't forget to do something. Okay, like you have to try out a few pages of algebra or any topic. Okay.
Mm.
So far so good.
Yes, for so good.
Okay, so see you on Thursday then. All right. Goodbye.
Yeah. Goodbye.